Time we done a basic internet networking device discussion. Yes or no? Data flow on switch, packet flow on router. So today topic name is which one? Today we discuss a topic is IP address. Which one topic? Loyal Neil copy. Topic name IP address. Okay. Basically, you're working as a network engineer, so IP address is very important. This IP address we can assign a which one devices only? Which one devices only? A layer 3 devices. Clear? Now, layer 3 device support IP address. IP means the internet protocol, or address means it's a logical or physical. So basically this side we write down address. Right now, address available two types. We are getting a version 4 and which one version, dear? Version 6. Today we discuss version 4, then we also discuss version 6. That means IPv4, that means IPv6. Now one more thing, for IPv4 called internet protocol version 4, and one more thing, it's called logical address. It's available in numerical values. Which one values, dear? Numericals values. And one more thing, this address is provided by which one organization, dear?
Yeah.
INA. INA means Internet Assign a number of authority. Now one more thing for IPv4. IPv4 size, how many bits, dear? 32 bits. One more thing, this bits are convert into how many bytes total? 4 bytes. So in 1 byte, how many bits available? Basically 8. So in a 4 byte, 32 bits. One more theory. IPv4 address example. For example, I will write down some address. So 10.7.5.1. So this one is your IPv4 address. In address, this one is available in one box, this value available in one box, this value available in one box, this value available in one box. Every box separated by a dot. So in IPv4, this box is this one, and this one. We are calling which one information? Octet. IPv4 total, how many octets available?
4 octets.
4 octets. IPv4, every octet separated by
dots.
A dot. IPv4, 1 octet size. How many bits, dear? 8 bits. 8 bit means total 4 octet. How many size? 32 bits. Now one more example. If I am saying this one is your single octet, this one is 1 octet. So how many bits? 1 octet?
8 bits.
8 bits. So in this octet, how many values we can put? So use formula 2 power 8 bits. So how many values come out? 256. But in this box, we can fix a range. 0 to how many values we can put? 255, because size is 8 bits. Now, one more thing. IPv4 address divided into classes. So right now we are getting some class and we are getting some range. So which one is class? A class A, class B, class C, class D, and class E. Class A range 0 to 127. How to get this range? Because in 1 octet, this value we can fix now. Class B 128 to 191. Class C 192 to 223. Class D 224 to 239. Or class E 242. Which one? 255. Okay, now one more thing. From class A, reserve addresses. So basically class A 0. If your address is starting from 0, it's a reserve. Reserve. For which purpose? For DHCP process. We'll discuss why we use DHCP process 0. If your address start from 0.1.1.1 or 2.2.2, any other 1, 2, 3, 400, 7, any address, but starting from 0, so reserve already. For which one purpose only? DHCP process. And one more thing. This range address not possible to assign end devices. End devices means, anyone know? PC, laptop, printer, IP phone, cameras. Clear? Now one more thing. From class A, if your address is starting from 127, it's also reserved. Why we reserve 127?
For loopback.
For NIC card testing. If you're having a LAN card, if you're having a WAN card, wireless, if you want to check your Wi-Fi adapter, it's working or not working, so you can do a testing. Because NIC card reserve this address 127.0.0.1. So this one is my which one address, dear? Loopback. If you're getting a reply from this loopback, that means your hardware and software it's working. Clear? Right now go to CMD and try to do a ping 127.0.0.1. Right now we are getting a reply, that means LAN adapter or WAN adapter is working. Now if I am doing a ping this address, ping 127.1.100.200, so this address get reply or not reply? Anyone know? This address possible to get reply from my WAN adapter or LAN adapter?
No.
Basically WAN or LAN adapter only reserve 127.0.0.1, but developer fix 127 for loopback. If you're having a 127 starting and rest of the 3 octet any value, so we can verify, because complete series reserve. Yes or no? Verify, we are getting a reply. For example, if you do a ping 200, 200, 200, we are also getting a reply. So developer fix 127. Which one, dear? 127. If you ping any address, then we can get reply. Now, so if you remove 0 or 127, so how many valid range available in class A now? 1 to 126. Now, one more thing we need to discuss. Increase the slide size. IPv4 address types available. We are getting a 2 types address. First address is which one, dear? Private address, and second is public address. Okay. First thing, this address available from class A, class B, and class C. This address always use locally. This address free of cost. Clear? One more thing. This address never access internet services directly. Now, which one address remaining? Public. What is the meaning of public? This address available in class A, class B, class C. One more thing. This address can use locally or publicly. This address need to purchase from
The ISP.
ISP. One more thing. This address possible to access directly internet services. Clear? Now one more thing. After address type, we are also getting one more information in IPv4. IPv4 address some octet fixed, some octet free. Fixed for a network by default. Which one, dear? By default. Free for a host, or you can say for devices by default. Now, before doing these things, must be clear one more point. Class D only used for which one purpose, dear? Multicasting. Class E reserved for a research purpose. If you are using a new technology, 5G, 6G, so we are using for this address. Multicasting means one device stream a video and others devices will use. If you're watching a FIFA, yes or no? So we are receiving a live streaming now. So in live streaming case, we are using a which one addresses, dear? Class D addresses for multicasting. Now, in IPv4 address, some octet fixed for network, some octet free for host. Network means only for group, never used for other. So right now, this side we write down a class, this side we write down range, And this side we write down fixed octet for which one purpose only? Network. This side we write down free octet for only host. Host means a users. Right now this information available in box. And one more box we create. Now fix this one, and this one. Now, which class only validate for use? Class A, class B, and class C. Now in class A, a valid range, class A valid range 1 to 126. Class B 128 to 191. Class C 192 to 223. So basically by default, this one is by default information. In class A, 1 octet fixed for which one purpose only, dear? Network. In IPv4, how many octets available? 4. But in class A, 1 octet reserved for network. That means how many free? 3.
125.
3 octet free for host. We can use for as a device IP addresses. Now, in class B, 2 octet fixed for network by default. So how many octet remaining? 2 octet free for
Host.
In class C, same. In class C,
3 octet for
fixed for a network and only 1 octet free for host. Done. It's a by default information. We can use all octet, but right now by default, if you read a books, if you read a Cisco Press any books, so we can get this information by default. Now one more thing. If you discuss IPv4 address, an IPv4 address, one more person is coming. This person name is subnet mask. Subnet mask means this feature will define in address how many bits, or you can say octet, fixed or free. So basically subnet mask, we are getting a 2 types. First subnet mask name is dear default subnet mask, and second name is custom subnet mask. We discussed both. Default we discussed first. So last time we create this table, same table we need to use, paste this side, but we need to add one more part this side. So very simple. In 1 octet, how many bits available? 8 bits. So right now, if I'm saying 1 octet full or fixed, that means complete 8-bit in use. So right now, hold on. This side we write down one information. It's called subnet mask. But which one only we write down?
Default.
It's a very simple to create. In class A, how many octet fixed? 1 octet. Basically, if someone say in 1 octet, how many bits? 8 bits. In 1 octet, we can put only which value? 0 to 255. If I'm putting 0, that means we can add more value. If I'm saying this octet, if someone put 255, that means we can add more value? No, because we already put full values. 255 is last value, na? So if someone say fix or someone say free, so fix means 255 and free means a 0. So in class A, how many octet fix? 1 octet. So basically first octet we put 255 and how many octet free? 3 octet. 0, 0, 0. So this one is class A default subnet mask. Class B also similar. How many octet fix?
2
Two octet.
octets.
So 255, 255. And how many free?
2.
1, 2. In class C, how many octet fix?
So 255.
3 octet.
Yeah,
255, 255, 255. And how many free?
0.
Only one. So 0.
1.
This one is we are getting default subnet mask. Or if someone say DSM, DSM means default subnet mask. So class A, class B, class C, we are getting. Now, one more thing we need to discuss an IPv4 address. Hold on, increase slide. If you are using IPv4 address, how to identify which class of IP address in use? If someone asking how to identify which class of IP address in use. So it's a very simple method to identify if you want to verification about the addresses. So we can say, if I'm saying 1.128.10.7. So now verify. Verify.
This is class. This is
Which one? This one is which class of address we are using?
Class A.
Class A. Basically, how to identify? Only check which octet? First octet values. So can you please verify in my first octet which address? 1.
1.
So it's called a class A. Now if I'm saying 172.1.100.192. So this one is which class again? 172 means you can verify. No worry. If you have any confusion about range, so we are getting 172. So verify which class having a 172.
B.
Class B. Now, so we are calling this one is my which address? A class B. Now one more address. If you are having 100.192.240.172. So this one is which class?
Class A.
It's a class A because right now in class A range is 1 to
126.
126. Class B 128 to 191. Class C 190 to 220. So only check first octet. In first octet, how many values we can get? Anyone know? In first octet, how many values we can get? 0 to 255. Any possibility available? We are getting a 256 in first octet.
No.
No. Now one more thing. After this thing is clear, now one more information we discuss. IPv4 address. In single IPv4 address, we can receive in single IPv4 address, we can provide connections. Which connections? For example, this side we are getting a which one person here? A client. And this side we are providing which one? Server. This server available with which service dear? HTTP. And this server address is 100.1.1.1. And basically this client want to access. And how many clients we can provide to access this IP? How many client possible to access? So basically number of connection we can provide only 65536 in single address. If you're having a single address IPv4, so how many maximum connection we can provide here? 65,536. Anyone know? By default, automatically a Google server IP address, IPv4 address automatically change. Anyone know? Why change? Because at a time, multiple users trying to access Google server. Yes or no? So that is the reason we are getting automatically change IPv4 addresses. This thing is clear. Now, one more thing. Basically, if you're having a LAN design, this side we are getting some LAN users, this side some mobile phones, and this side we are getting some laptop users, and this device is connected with your modem. Some device physical connections, some device wireless connectivities. And this modem connected with which one side here? ISP, Internet Service Provider. Now, so basically this part, this one, we are calling a private. Which one dear? Private. And this part we are calling public. Now, ISP engineers will provide in private. Private means this one is my LAN side, and public means this one is my WAN side. Local area network, wide area network. Okay, right now in LAN side, network engineer will provide 192.168.1.0. So this one is which class address we are getting? Class C, because 192. From this addresses, we are getting first IP 1.1 for this one, 1.2, 1.3, 1.4, 1.5, and modem having a gateway IP is 1.254. So whenever this user want to communicate with this mobile phone, so first time this user verify a communication in between a same group, but destination MAC must be available. If MAC address is not available, so generate which one message here? ARP request. Whenever this person generate ARP request, so modem will receive, and same ARP request forward. How many users side here? All users. Clear? So this one is LAN design. But right now in IPv4 address, we are getting total address. Every class. IPv4 address. Now total address, how many available? So this one box we discussed last time. In class A, how many octet fix? Verify. Class A. How many octet fix? 1 octet. Class B, 2 octet. So right now we need to discuss total address. How many gates each class? So in class A, 1 octet is fixed. And how many octet we can use? 3 octet. So in 1 octet, how many bits available? 8 bit, or 3 octet means 24. So 2 power 24, we can get total address. In class B, 2 octet, that means 16 bits, 2 power 16. Class C, 1 octet, 2 power 8 bits. So basically, now use calculator again to get values. Each class, how many total number of address? 2 power 24. So I think 16777 value we are getting. Yes. So this one is number of address available in class A. If someone asking how many total address available in class A, so this one address is. Class B 65536. Class C 256. You can verify same values. 2 power 16, 2 power 8. Done. This one values we are getting a total number of address. So in this design, if I'm using class C, so how many total address available in my lens side? 256 address. But right now, how many addresses we already use? For example, we use 15 address. So how many remaining? 216. It possible to assign this addresses? No. So first issue we are getting IPv4 address wastage because we are not using. Second issue, if this person generate ARP request, so this modem will receive and this modem forward all users. Right now 15 user available and this modem also trying to find out where is 216 users. So in this case, modem also getting one more issue, CPU utilization and broadcast area. Broadcast receive unknown devices also. Unknown devices also. So in this case, we need to perform a subnetting. We create a small network, a small group. Number of address, IP address, number of IP address we want to reserve for only limited users. So without subnetting part, if we are using any class, so IP address wastage. So how to save this address? So we perform subnetting. So next session we discuss which one topic, dear? Topic name is, which topic we discuss, Neil? Subnetting. Subnetting topic we discuss. In subnetting we discuss some rules. Basically, if someone asking why we use subnetting part, this concept help to break big network into a small network as per requirement. And one more thing, this concept only work into subnet mask. We are not using addresses. We are performing this task only subnet mask. After perform subnetting, network engineer receive custom subnet mask. Clear? So subnetting topic we discuss in next lecture. Subnetting rule we discuss, how to perform subnetting, and subnetting formula we also discuss. Clear? Loyal, Neil, Gopi. This thing is clear? Okay.
Yeah.
So we meet again next session, but we start now subnetting part. Okay. So the video and we again meet and then discuss subnetting topics. So today we discuss only IPv4 theory and we discuss subnet mask, which one is private, which one is public, and we discuss how many octet fixed, how many octet free. This thing we done. Clear? Loyal Neil Gopi.